Okay, so this is 2C. And this one is sneakier than the other ones. So this is a three-part function. And notice, actually, it looks like maybe we have a removable discontinuity that we can fill in by assigning a value of a when x is equal to 1. Because look, on the bottom is this sneaky little x minus 1 thing. And it might be a removable discontinuity, or it might be an infinite discontinuity. The trick here is this is x squared plus 2x minus 3 on top, and it's x squared minus 2x minus 3 on the bottom. And that is where the trick lies. Okay, the top is fine. La, 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 la. We just factor that, and notice that we have repeated factors in the top and the bottom that cancel out. And so essentially this is a linear function, that top one, and it's just x plus 3, and we just have to make sure that x is not equal to 1. And so that looks like, yeah, that's a removable discontinuity, no problem. And when x is equal to 1, that is going to be equal to 4. That seems pretty straightforward. Unfortunately, so if we're approaching it from below, if we're approaching it from above, we have to deal with this one. So if we're approaching that point, x equals 1 from above, we're dealing with this function, and it doesn't factor. The top doesn't factor. At least it doesn't factor nicely. It might factor. Anyways, it certainly doesn't cancel with this value on the bottom. So we're actually going to get an infinite discontinuity at x equals 1 for this second branch of the function. So there is not going to be a value of a that is going to fix this. And let me show you why. So here we are on Desmos, and as you can see, I've got the function carefully made over here. And sure enough, here's this linear branch. Here's the linear branch of the first part. And as long as x is less than 1, everything is happy. There we go. As long as x is less than 1, everything is happy. The thing approaches 4, or we could assign a value of 4 for a and make it continuous right to there. Unfortunately, we get to this part that we can't factor underneath, and we have this asymptote when x is equal to 1. And so there's no way we can fix this one, because the limit from below is not going to equal the limit from above anyways. And so our definition of continuity, the limit from below has to equal the limit from above, and it has to equal the value of the function at that value. We can't fix this no matter what.